Good morning, friends. I'm Nikhil from Mindgate Solutions. I'm heading product and innovation team at Mindgate. I've been working since last 10 years as a technical architect. Thanks for inviting me over for this presentation. So Mindgate is a company that was founded in 2008. We have almost 1,000 plus payment professionals. We also have 50 plus global customers, India and Middle East and Southeast Asia. Uh, we are processing close to 3 billion digital payments monthly, and with the transaction per second speed of 20,000 plus, which is proven in our labs. We have clocked almost 5,000 TPS in the largest banks of India, which is SBI, and also a key customer. There are large banks like SBI, SDFC, Yes Bank, HSBC, Citi, Bank of America uh, are our key customers. So today we'll talk about the challenges in deploying real-time payments on the traditional RDBMS systems. We have been using RDBMS almost last 8 years in our applications, and the growth of real-time payments in India has asked us to work with modern databases like Yugabyte, and there are various challenges that we have faced with the growing volume. We are processing as of now close to 50 million transactions per day in our large customer. So but we understand that the current RDBMS setup they should be fine tuned to high scalability and predictable performance. Banks are targeting for their systems and databases uh, to be handled at least 5x to 10x growths. So today we'll discuss how uh, we and other organizations are leveraging this modern databases to deliver the scale and actually a true active setup for the critical applications like UPI. So real-time payment in India has a very large use cases, and there are different scenarios and use cases are being added on almost every month by the regulators like NPCI and RBI. Currently, we are processing kind of in real-time use cases, instant payments, your push and pull and QR are the highly used use cases. Other use cases are like your capital market payments, which is your IPO payments. There are online disputes. There are in-app payments called intent payments. There are also cross-border payments, and they go by the foreign inward remittance and foreign outward remittance. There are new features recently added called UPL Lite, which gives you a kind of a wallet for real-time payments. It has a goal to achieve offline payments itself. There are other use cases like IVR-based payments, bill payments, corporate collections, even toll payments. All these payments use cases are riding on our real-time application, which are kind of using a traditional RDBMS as on date. So what we usually this I'm displaying a current setup of typical database here, which we have a primary site, we have a DR site, and it is most of the banks are running it on a private cloud on a VMware rack, and there's replication. There is a async replication between both the sites, and there are kind of manual backups and archivals and data retention almost up to 6 months based on the various business use cases. The current setup gives an RTO of about 30 minutes, and during the BCP drills, and typically it's a 4 to 6 node rack setup. The key challenges that we face are kind of both real-time and operational challenges. So some of the real-time challenges are when there is a high volume or peak volumes, we see a large pileup of active sessions. Sessions go as high as 5,000 in real-time basis, and during that time we see a slow response time from the database. A typical good response time is under 50 milliseconds, but in a peak volume period or in a evening scenarios where we have got large volumes and large transactions coming in, the response time becomes as high as 200 to 300 milliseconds, which causes our system to choke our applications. Kind of the high throughput is impacted, and the transaction starts declining. Um, we also see index contention of large transaction tables, where on the uh, days like there are surges during IPL matches, there are surges during flash sales, which so this database is not able to handle those surge in transaction volumes. Sometimes you also see a high latency, typically interconnect latency between multiple nodes, which is caused by the sync up between of data between two nodes. Plus, sometimes there are issues with storage latency. There is a high latency on the storage disks. There are also other operational challenges like the sync up time between two sites, or you can say cross-site replication is quite high. The RTO RP of our application is kind of because of database replication dependency is as high as 30 to 60 minutes. Plus, there is a manual intervention during backups and archival, which causes us operational issues, and we're not able to automate these archivals and backups. So these are the key factors that which help us to decide our migration strategy to Yugabyte. What we have seen is that Yugabyte gives us really low latency reads and high throughput writes. The sync replication between clusters across data centers across regions is without any latency is a key factor for us. The raft consensus algorithm, which kind of replicates data between multi sites and with a very good performance, is also a decision factor. And the one more important feature is that inbuilt sharding mechanism, which helps us to distribute our data across multiple shards, so that there is no all transactions are not kind of piled up on a single data table. They are distributed across multiple shards. Plus, it supports SQL and NoSQL in the same cluster, where we can run our applications with asset properties of database in a typical real-time payments. Plus, it gives a benefit of analytics. We can perform analytics reporting on a NoSQL feature with various factors. Because systems, banks are demanding the reports for each and every indices. For example, reports on time basis, reports on bank basis, reports on account number basis, reports on merchant ID basis. So there are various factors where, and we can't keep on adding too many indexes into our setups. Therefore, NoSQL literally helps us to gives us the good analytical and reporting platform. The key benefits that we have seen is the core architecture of the Yugabyte, which is highly scalable, and it is linearly scalable, and it has its automatic failover and native repair mechanism. And there is no single point of failure, and all nodes are kind of equal. There is a leader and then there's a follower. But from data perspective, every node works seamlessly. And it's got a proven DocDB document store, which is common across YSQL and YCQL APIs. It also builds a custom raft replication logic, and it has got a RocksDB storage engine, which is already proven in large RDBMS setups. The objectives that we have achieved with Yugabyte, it supports exponential growth with hyperscale. And we are able to achieve performance, efficiency, and reliability with this. It gives us cloud agility with the security as well. We are with Yugabyte, we are able to migrate our on-prem setup to the cloud. We are running successful products on cloud now with the help of Yugabyte. It does give us provisional economic business value as well compared to other RDBMS systems. That is also interoperable and flexible design. We can use our application can use multi-database feature. And there's also a key feature called change data capture, which is a CDC, which we can sync up with any of the data warehouse or data lake systems given by the banks. So with this, I'd like to end my sessions and thank you for inviting me over. Have a good day.